Hello, welcome. Let's continue to solve another Leetcode problem. 1335. Minimum difficulty of a job schedule. Let me first explain the problem. Basically we are giving a drawing, but it doesn't matter. It just makes the problem explainable. So for example, let's try to understand. We have a job difficulty. So there is a sequence for the job because, for example, we must finish 6 and then we can finish this number 5, and then we can continue to finish this number 4 because there is a sequence. So this is just an array splitting problem. So for D2 it means just we need to find a point. We need to find a line, and this line will split the array into 2 parts. We just need to calculate the maximum value of the left part and the maximum value of the right part. For example, the left part 6, 5, 4, the maximum value is 6, and what about the right side? 3, 2, 1, the maximum is 3, so it is 9. But we want to calculate the minimum value. So what about we have another split? For example, we split from this 2 and 1, between 2 and 1. So for the left side it is still 6, but for the right side it is 1. So 6 plus 1 it is 7. So 7 is going to be the minimum. If you are familiar with such kind of a problem, it's going to be really easy because this is just a split DP problem, and technically it is a multi-dimensional DP problem. The idea is we are having an array. We want to split the array into different parts. If there's one split, it means this d equal to 2. It means it can be separated to 2 days. If there's a 2 split, it means 3 days. Now we just need to calculate the sum of each part, but for each part it must be the maximum, and we're gonna calculate the minimum of each part. So this is a typical DP problem. So I'm gonna use dynamic programming to solve it, but I'm gonna use the DFS plus memorization. Let me put a DFS with parse, because I didn't find a way to define the DFS. Let me find a way to define this DFS. But we can have some edge cases check. So for example, if the length of the job difficulty is less than this d, so we're gonna return a -1. So let's have a check of this one first. So n should be equal to length of the job difficulty. So if n less than d, we're gonna return a -1. This means there's no splitting. So otherwise, I'm gonna prepare a case and prepare the DFS. So my DFS, finally I'm gonna return this DFS. So for the DFS, I'm gonna starting from the first place in index 0, and I'm gonna define a variable d. So this d basically means let me make it smaller. So this d basically means it is the split is just starting from 0, or I can make it 1 maybe. So this d is just means the day. So this means from the beginning I will define it as day 1. If there's a split, so it will become day 2. So this is just according to the description of the problem. So I'm gonna define a day 1 for the easy calculation. So from beginning it is 1. If this number, so this is the index and this day. If this day becomes 2 for the first example, so it means there is 1 split. Because 1 plus 1 it is 2, so there is 1 split. It meets the cases. So I'm gonna first of all check this day. If this day equals to d, I'm gonna check if there's a split or not. So currently, I don't know what to return, but let me just return a negative infinity first. Basically I need to return the I need to have a check. If this I less than n, I need to return the maximum of the left part. So what left behind? Maximum of the left part. I mean left behind. So this is the job difficulty from I to the right side. So this means, for example, from here I find a split. So if d equals to this d, it means I'm gonna check the maximum from this one to its right side. Yes. Else, if this I equals to n or more than n, it means this I goes out of the boundary. So it is not valid. If it is not valid, I'm gonna return a minus infinity. This is because minus infinity can prove that is not valid, because I'm gonna use the minimum. Yeah, I'm gonna check the minimum value. So inside the DFS. Yeah, I'm gonna explain this one later. So this is equal to d. So if this d more than d, I can still return a negative infinity. Yeah, because this is just an invalid case. If we choose positive infinity, it is not possible. Positive infinity is valid. We have to choose an invalid case. If it is invalid, we have to choose negative infinity, and then the result will still be negative infinity, because we always choose the minimum value. Yeah, because this one, the result is always the minimum value. Now let me prepare a result. So the result would be positive infinity. So for I, this is I for j. Now I'm going to split it in I plus 1 and to n. So the result would be so from here we're gonna check the minimum value. Yeah, minimum result with the DFS inside. So yeah, first of all, so this is j, it means go to the next position. So here it should be j, and the day should be plus 1. Yeah, because we have a split, so we're gonna plus 1, and then we're gonna plus the maximum of the left side. So yeah, so here is the right side. We're gonna check the right side, but for here we're gonna check the maximum of the left side. So that is from I to j. So basically it is a job difficulty from I to j. So this means, for example, we're gonna check, for example, from 6 to 2. This area is the left behind, so this is I to j, and then we're gonna check the maximum of the right side from 1 to the right side. Yeah. Finally, we're gonna return this result. Yeah. Now let me explain why I'm gonna return a negative infinity. Because for this result is our final return, we want to return a minimum value. If I choose a negative infinity, so my result would still be negative infinity. That means it is not valid. So this case is not valid, and of course this case, else case, is also not valid. So this proves our negative infinity is right. Now I think it's time to run it to check. Yeah, as you can see, it passed the testing cases. Now let me submit it to check if it can pass all the testing cases. Basically, this problem is not so difficult if you are familiar with the dimensional DP with the split problem. Yeah, but it's really slow. As you can see, it is just 2 seconds. Yeah, so this means we can improve the time. So we can improve it by these areas. Because for here, this is ON. Yeah, let's check the length of the job difficulty. This is N, and this D is M. Yeah, so this is n, and this is n square, and I is n, so it is n cubic times day. Basically, the time complexity is n to the power of 3. Yeah, let me use n to the power of 3 times m. Yeah, this is a really big value. This n is 300 to the power of 3 and times 10. It's gonna be a really big value. Normally, it cannot pass. But if it passed, we can still optimize it. We can optimize the maximum value from here. Yeah, because this is just calculated the previous value. This previous value is just coming from this for loop. Yeah. So from here, we're gonna define another variable, local variable of maximum. So from the beginning, it's gonna be 0. And here, we're gonna check the maximum value. So this maximum would be the max of the maximum of the previous calculated value. So the value should not include j. It should be j minus 1. So it means the job difficulty j minus 1. Yeah, because this is for another array. This is j to I plus 1. This means to another array. But we want to calculate the maximum of the previous array. So it's going to be the job difficulty j minus 1. And here, we're going to update this to the maximum. Yeah, to mx. Yeah, as you can see, now we turn the problem of n cubic to n square from here. Now let me run it and submit it to check if it can improve the time. Now as you can see, the time becomes 0.5 seconds. Before that is 2 seconds. Normally here is also can be optimized, but I will not do it this time. I think you can check that job difficulty is just from I to the right side. Normally you can use a suffix sum to calculate this value, and here would also become 01. Yeah, let me just do it. Let me just do it from here. So we're gonna prepare a suffix array. So the suffix array would be job difficulty minus 1 times n, and then we're gonna use a for loop. So for I in range n minus 2 minus 1 minus 1, and we're gonna check the suffix I should be equal to the maximum of job difficulty I with suffix I plus 1. Yeah, now we prepared a suffix array. This is the maximum array from this value to its right side. So it means from here, we just need to use job difficulty, use the suffix array. We're going to use the suffix array with this I. Yeah. We don't need to use the maximum. We're going to directly calculate it from the suffix array. So this is the on time. And from here, this is n squared times m. Now let me run it and submit it to prove that it's right. Now as you can see it, with the time it's nearly the same, but actually we improved. Yeah, because technically speaking, if we didn't optimize here, the time complexity is still n cubic times m. But that is because we optimized these areas. It seems that the time is length. But for calculation, for big O notation, it is still n cubic until we calculated the suffix array from here, and then the time complexity for this DFS plus memorization becomes n cubic times m, and the space complexity is m times n, because this is just a test. Yeah, so that's all for today. Thank you for watching. See you next time.